Hi and welcome to this next video in our series on differentiation, and in this video we're going to be looking at the mechanics of differentiation, like physically how do you go about actually differentiating stuff. You should have seen in the previous videos how to differentiate first principles and what is going on behind all this, but this video is now just looking at how you physically go about doing it. So we've done all the stuff that's grayed out there, that's all covered, so let's have a look at how we go about differentiating. First thing we're going to do though is just have a look at a few little bits and pieces that pop up, just to make sure that we're entirely happy with them, particularly what's happening with regard to a constant number on the end of a polynomial. So let's just have a look at this example. So we're going to start off with a sketch of y equals x squared plus 3x, do a bit of factorising. Okay, there we go, and there's our sketch, all fairly straightforward stuff. So now we need the gradient of that curve. And so what we're going to do is differentiate it. Remember our rule, kind of the easy way to think about it is like bring the power to the front, take one off the power. So here we go. So dy dx, the differential or the gradient function is, so for the first part, where's my mouse? There it is. So we're going to bring the power to the front, take one off the power. So x squared becomes 2 times x to the power 1. There's comes to the front. There's the take one off the power. So we've got that. All fairly straightforward. The one that's needs a little bit more thinking about, but once you see how it works, it will become very, very simple, is the next term, which is this one here. So this is currently 3x to the power 1. So the 1 comes to the front, so there it is. The 3 is still there, so still times over that. But the key thing here is the take 1 off the power 1 becomes power 0. And as we know, anything to the power 0 is just 1. So that whole thing just becomes 3. So it's one of those kind of those few times where we say like kind of the x just effectively, it looks like it's disappearing. It's not. It's becoming x to the power 0. But as far as we're concerned, when you differentiate 3x, you just get 3. So there's our gradient function. When x equals 1, the gradient is what we've got to do is say, well, when x equals 1, so we're about here on our curve, so we need the gradient of the graph that's somewhere about here. So when x equals 1, let's just put it into the expression. So clearly that's going to give us a gradient of 5. All done. Right, so that was part B. Moving on to part C, what I want to do is have a look at that curve there, which is y equals x squared plus 3x plus 7. And you'll have noticed that essentially there's the x squared plus 3x, same as we had from part A, but we've got this plus 7 on the end. We just kind of have to think about what impact that's going to have on the gradients. Now, hopefully, we're quite happy that if we've got y equals x squared plus 6 plus 7 is just simply a vertical translation of that one. It's the same as this function here, but with 7 added on the end. So all that's happening is it's the same curve, just getting shifted straight up. So you can see here's my blue curve that I've shifted up 7 places. Now what that means is if we take the value when x equals 1, this point here has got exactly the same gradient as this point up here. The fact that the curve has moved upwards has had absolutely no effect whatsoever on the gradient. The red curve and the blue curve are parallel. So what that means is the gradient is 5. So essentially what's happening is when we differentiate, this function, this kind of value on the end here, essentially just disappears. So the gradient function of this, y equals x squared plus 3x plus 7, will be 2x plus 3, exactly the same as the gradient function of our red curve. Okay, now we've got all that figured out, the deal with what happens with x to the power 1 and what happens with our constant terms, let's just have a go at doing some differentiating. So the first one, we'll just take it one term at a time. So here we go, y equals x cubed minus 4x squared plus 7x minus 5. So that gives us, first term, differentiate that, we're going to get 3x squared. The next term, power 2 comes to the front, so that's going to become 8. So we've got minus 8x. The 7x, that's just going to become plus 7. And then here's our constant term that is effectively just going to disappear. So there we go. That's all that one there. You go gradient function of your cubic. So on to the next one, part B, where we've got a slightly different notation we've got to deal with because we've got function notation going on. And also we've got to deal with the fact that these are set up as cube roots and we've got kind of a power on the bottom here. So this is where we're really going to be making use of all the work you did on your index laws and writing roots as powers right at the start of the course. So what we're going to do is take this, and the first thing we've got to do is get this written in terms of powers, so we can't, rather than having it as a root or this power on the bottom, we need to write this using index laws. So here we go. So first thing I'm going to do is just rewrite that function, and hopefully we know that cube root is the same as power third. So that one's going to get written as 5x to the power of third. And then if we have a look at this one here, we've got to be really careful here. These ones where students tend to make most mistakes. What I'm going to do is just a little bit of extra scribbling if I can. So what I'm going to do is take that fraction there, which at the moment is 2/3 effectively times by 1 over x squared. Now, I apologise for the slightly rubbish writing, but you know, it's not the easiest thing to do on a mousepad. So we've got that. So it's essentially this bit here that we need to write as a power. So that is just going to become x to the power of -2. So what we've got, the whole thing would be 2/3 x to the power -2. What you tend to find is a lot of students will start trying to kind of write the 3 as a -2 as well, and all kinds of silly stuff. So that's what we've got. And so well, let's just get rid of that. Here we go. Let's get rid of all of that. Now we've sorted that. Okay, and turn the rubber off. And so what we've got is -2/3 x to the -2. Now we've got it written in terms of powers, we can do the differentiating. So here we go. First one we've got to look at is this. Oh, sorry, before we do, we've got this function notation here. The equivalent gradient function notation is f dash. You just put a little dash there. That means like kind of the gradient function of a function. So that's our notation. And now first we're going to do with this one, bring the power to the front. So we've got 5 times a third. And take 1 off the power. If we take 1 off 1/3, we're going to get -2/3. So we've got 5/3 x to the power -2/3. And then for the next one, again, bring the power to the front. So I've got -2 times by 2/3. That's going to be 4/3. Take 1 off the power. A lot of people sometimes will end up with a -1 here. That's actually going to be -3. And notice as well, we've got this thing that's popped up. Clearly, we've now got a plus here because when the minus comes to the front, we've effectively got minus times a minus making a plus. So that's where that plus symbol has come from. And so there we go. There's our gradient function. Moving on to part C, we've got brackets here. So what we're going to do is kind of multiply out the top and then do a whole bunch of tidying up. So here we go. Multiply at the top, we've got x to the power 4 minus 2x squared plus 1, just expanding that bracket, and the root on the bottom written as x to the power half. Now again, we've got to get these each individual terms written as powers. So what we're essentially doing is saying, okay, we've got to do x to the power 4 divided by x to the power half, minus 2x squared divided by x to the power half, 1 divided by x to the power half. To do that, let's have a look at the first term. So we've got x to the power 4 divided by x to the power half. We should know that what that means is you've got to subtract the powers. So that's going to become power 3.5 or 7/2. Same deal here, x squared. Subtract the half, that gives us 3/2. And then we've got 1 over x to the power half, which is x to the minus half. So if you're not quite sure, just take a moment, pause the video and have a little look and make sure you're happy where I'm getting all those numbers from. You can use decimals, it's absolutely fine. I always prefer to work in fractions, but essentially that's your choice. What you want to do, both would be okay. So now if we're going to differentiate, so again this notation is saying we're going to differentiate with respect to x, this expression here, and off we go, bring the power to the front, knock 1 off the power. So we've got 7/2 x to the power 5/2. Bring the power to the front, so we've got 3/2 times 2, so that's going to become -3 x to the power half. And again, bring the power to the front, so that's going to become -1/2. Take 1 off the power. That gives us -3/2. And there we go, all done and sorted.